Alright, this is now page 13 of the white pages in your supplemental text. The first questions, let's look at part A. We have the equations y equals 3x plus 1 and then y equals 6x minus 0.5. And it asks you to solve the following systems graphically. You need to solve for y, then put the equations into y equals on your calculator. Step 1 is done. They're already solved in terms of y, so that makes our life a little bit easier. So here's my calculator, and I'm going ahead and typing in those two equations. So I'm going to hit the y equals button, and then 3x plus 1. I'm going to hit enter, and now in y2 I'm going to enter 6x minus 0.5. And before I hit graph, I'm going to follow the directions, and I'm going to hit zoom. I'm going to hit zoom, and then I'm going to go down to number 6 for Z standard. I could either type the number 6 or move the arrows down to 6 and then hit enter. Now it will graph the first line and the second line. Now what I need to do is find where they intersect. To do this, I'm going to hit second and then trace, and then go down to number 5 for intersect. I'm going to just hit enter, enter, and then enter, and I get the answer of x is 0.5 and y is 2.5. So this is the point 0.5, comma 2.5. And here's our next set of equations. What we're trying to do is find the one point that makes both of these true. Well, if I look at this one, the second equation, I first have to do something with because it's not y by itself. On my calculator, I need y by itself in order to use those y equals on the graphing part of the calculator. So to get y by itself, I'm simply going to divide both sides by 3. And I can't just divide the negative 2x by 3 or the negative 6x by 3. Every single term has to be divided by 3. So that gives me y equals negative 2/3 x minus 2. Negative 6 divided by 3 is negative 2. So now I'm going to take these two equations, the equation 1, which I didn't have to do anything with, and equation 2, and let's go back to my calculator. Alright, the first one we're going to type in negative 4. Now notice I'm not using minus 4. I'm not using the subtraction symbol. This is a negative number, so I'm using that parentheses and that little dash. That means a negative 4x plus 10. And that's my first equation. My second equation is going to be negative 2/3 x minus 2. Now looking at this, it's hard to tell what's going on with the 2/3. Is it 2 divided by 3x or is it 2 divided by 3 times x? Let's just make it really straightforward, and I'm going to go ahead and use parentheses. It would have been fine, but I think it's much clearer if we write it out this way. Alright, so now again I have my two equations. I hit zoom standard, and again they're going to intersect. And I'm going to hit second trace. I'm going to hit intersect. I'm going to hit enter, enter, enter. And I get that point of intersection being x is equal to 3.6 and y equaling negative 4.4. And that would be the answer I would write down for B. Let's do the last one, number C, or letter C. Alright, here's my two equations. Now my first equation has an x on the same side as the y. I need to get rid of that, so I'm going to subtract 2x from both sides. When I do that, my first equation is y equals negative 2x plus 3. So now that's ready to type into my calculator. The second equation, just like this last example, I have to divide everything by 2, and then I get y equals negative 2x plus 5. And that's my second equation. And again, I'm going to go ahead and type this into my calculator. Y equals negative 2x plus 3, and then negative 2x plus 5. And I'm going to go ahead and hit zoom, standard, first line, and the second line. Looking at this, I don't see where those cross at all. And that actually is one of the things that can happen when we have two equations, two linear equations. In this case, we have no solutions. We have two parallel lines that will never, ever, ever touch each other. So that is one kind of solution. Usually we get a single point, but sometimes we can also get no solution.